Before we get started, this is just a reminder that in the video description, you'll find a GitHub link that has all the materials associated with this series. So in this series, we're going to build and deploy custom virtual machine images across AWS, Azure, and Google Cloud, all using HashiCorp's Packer tool. You'll get a complete end-to-end example you can use in your own projects and adapt for your own use. We're going to build 2 VMs from scratch. First, an Ubuntu 24.04 image. We're going to use the apt package manager to install Apache and then deploy some 80s style JavaScript HTML games into that Apache server, so it'll become a game server. Second, we're going to deploy a Windows Server 22 image. And in that, we're going to first apply Windows updates. So at the time of the build, the Windows server you have will have all the OS patches as of that date. And then we're going to install Chrome and Firefox so that when you log in with RDP into that box on your desktop, you will have Edge, which is included with the Windows Server build, and then Chrome and Firefox desktop links on your desktop. Along the way, we'll learn the nuances of how Packer works across the different cloud providers, with most of the complexity centered around building Windows images. Linux images build a lot like Docker images. It's just a bunch of bash scripts that get run over SSH. So Linux is much easier or much more consistent across the cloud providers, and Windows will have to make adjustments for the various cloud providers. By the end of the series, you'll have that end-to-end working image across AWS, Azure, and GCP that you can then adapt for your own use. In the AWS solution, we're going to focus on the key steps needed to build and deploy custom AMIs successfully. For Windows, we configure WinRM during the build by injecting a custom user data script. AWS requires the most configuration of WinRM. If you look at the custom user data script that's in the project, you'll see that it enables it, adds a password, adds the account to the right administrators group. So for Windows and AWS, WinRM requires the most configuration. At the end of the deployment, after we have run all the PowerShell commands through WinRM, when we use the EC2 launch tool to take a image, to run Sysprep so that we can take an image. This is key for setting things up so user data will run properly on the new image, that it'll get a license, that the metadata URL links work. So it's key on Windows for you to run this EC2 launch. Otherwise, you're going to end up with a AMI that's not going to boot properly. Now, for Linux, SSH is used by Packer for provisioning. It creates a temporary user ID and password, and then it's going to go through the scripts and install Apache. It's also going to enable Apache, and then it's going to move over the HTML code for the games. And then it's going to call, at the end, it's going to call to create an image and push that image into your account. Now, both Linux and Windows image are configured for AWS System Manager, SSM. This allows us to connect from the AWS console without having to have a public IP address, although we do have a public IP address, but it just makes it easier to debug. You can also create a PowerShell session and connect to the Windows instance with SSM. Once the images are built, we're going to deploy a Linux EC2 for the game server, and then we're also going to deploy a Windows server that we can RDP in and test. Now, we create local accounts in both images, the Packer account, and in that, we set the credentials to a random password, and then we publish that random password into the Packer credentials secret. So that will allow us to test both SSHing to the Linux game server and also RDPing to the desktop AMI or desktop server. So briefly, to look at what gets built by the end of the build, you've got your US East 2, your account. Now we create a VPC and we have 2 public subnets. Now I did 2 out of habit. You really didn't need to for this one because there's no high availability constraints or configuration options since we have one server. But when one AZ, we put the Linux game server, and in the other one, we do the desktop server. Now, the outside of your VPC, you've got the games AMI, and then you also have the Packer credentials, which is the secrets that you can retrieve, and then you're going to have the desktop AMI. So it's a really simple build as far as what actually in your account, but Packer does most of the heavy lifting in this project. Next, let's take a look at the Azure Cloud Solution. Now, in the Azure Solution, we're also going to do the Linux instance, and it's going to use SSH just like the other clouds. The Linux provisioning in the Ubuntu 24.4 image is the most similar VM creation or VM image creation across all providers. To select the right AMI or the right image to start with, and then once you're done with that, the runs happen very consistently. For Windows, Packer provisions the entire configuration for WinRM. So it's really nice that of all the WinRM configurations, Azure does the best. And it kind of makes sense because WinRM is a Windows protocol, Azure is Microsoft, so it kind of makes sense that they do it the best. Now, at the end of the Windows build, we do have to call Sysprep, and we call it manually. There's no tool like EC2 launch tool in Azure. You have to do it manually. And the options are slightly different than what you'd use in GCP. But once you know them, it's pretty straightforward. To debug and manage our VMs, we create a Azure Bastion host that allows us to interact with the both RDP and SSH within the console without having public IPs. Of course, we do have public IPs because we're publishing these publicly for testing purposes. But Bastion is a quick way of debugging your environment without having to have everything public. Once the images are built, we will deploy a Linux VM running the HTML game server, and then we will also deploy the Windows Server VM, and we'll access them through Bastion. Now, again, we create these Packer credentials for accessing RDP and also SSH, and those Packer credentials are stored in a key vault that we create in the project, and we'll walk through how you do that. So briefly, let's look at the architecture diagram for this the Azure solution. We've got two subnets. We've got the Bastion subnet and then the Packer subnet where we put the deployed VM instances. Remember with Azure, subnetting is not segmented by availability zone or data center. It's by function. So our two functions are Bastion and then our deployed servers. Now you can have, these could be in different availability zones or zones, but for our purposes, they're all in the same one because there's no real high availability aspect to this project. So that's within your virtual network. Then outside your virtual network, you've got the game image that's built with Packer, and you have the desktop image built with Packer, and then you also have the key vault. Okay, now let's look at the GCP solution. In the GCP solution, the Linux provisioning is handled over SSH. Just like in AWS and Azure, the Linux provisioning is very similar across all three providers. You just have to pick the right image to start with, and then everything else works pretty much the same. For Windows, Packer also uses WinRM for provisioning. And here, it's somewhat in between AWS and Azure. It doesn't do all of it. It does start and install the WinRM protocol and provision the certificate and do all the things that needs to be done there, but you do have to set a specific password and just some final last mile configuration it doesn't do for you. And so what we have to do is we create a metadata startup script that does those last two options. And finally, at the end of the Windows build, we're also going to call Sysprep directly, just like Azure. The options are slightly different, but the key thing is there is no tool like AWS, that EC2 launch tool that does all that stuff for you. Now, one of the things that's unique to the GCP solution is that the WinRM traffic port, which is 5986, is not open by default. The other two providers either provision a network security group or use a network where everything's open. And so what you're going to have to do is you're going to have to create your network and then add a firewall rule for 5986. Otherwise, Packer will not be able to communicate with the new instance. So that is a sort of a nuance of the GCP. Now, once the images are built, we deploy a Linux VM in our VPC, and then we do a desktop VM in our VPC. And so let's look at the diagram. It's very simple. And what we're going to do is we have the Packer VPC, Packer subnet. This is where the games instance that are copies or instances of the image are deployed. Then we have the images in your project, not in the network. And then we also have the Packer credentials secret. So just like the other environments, we're going to spin up these instances and set passwords, so local account Packer credentials, and we're going to take the generated unique password and put it in Packer credentials. And when we go through the demo, you're going to see where we have to go pick the credentials and to do RDP. You can also SSH to the VM instance, so there's a local Packer account in each environment. Okay, so now let's take a quick demo of one of the solutions. We're going to look at the Azure solution. So let's go to our build output, and you'll see two DNS names, the desktop name and the games. So let's first test the games. I'm going to copy this, then I'm going to go to a web browser, open up a new tab, and click there. And my personal favorite is Frogger. This should have all the games. Right. So much for that. So that is your games. It's got all of them. They're pretty old games, but it's that's been deployed. So I'll close that. Now we do have a name for the DNS name for the desktop, but we're not going to access it this way. We're going to use the Bastion configuration in Azure. So I'm going to go and bring up the browser again, and I'm going to go in the Azure console, and I'm going to click on resource groups. I'm going to look at the resource groups here, and you're going to see everything this project got built. We got the Bastion, and we got everything associated with the deployed desktop instance and everything associated with the games instance. And then the images are in here as well. And so we're going to do RDP using Bastion into the desktop image. But the first thing we need to do is we need to get that password from the key vault. So there's Packer credentials local credentials created on both VMs. We're going to have to go in and get that secret value. So I'm going to go to secrets, and I'm going to click on Packer credentials, current version, show secret value. I'm going to copy that right there. And now we're going to go back to our resource group, and we're going to go to our desktop image. Using Bastion, I'm going to do connect via Bastion. And I'm going to say my user ID is Packer. Password is the one we just got out of Secrets Manager. And now let's hit connect. Now let's take a few minutes to connect. And so we will, there we go. It's connected already. And so what we're going to do here is we've got the three browsers. We got Chrome, Edge, and Firefox. What we're also going to do is we're going to do check for updates, and it should say it is last checked 2/11 today, and we are all done. So this has the new browsers. It also has the Windows Update completed, and we're logged in using the Packer account that was provisioned during the Packer build, and the credentials are stored in Secret Manager, Vault, whichever one is the appropriate for each cloud provider. So that's what we're going to do. We're going to show this solution for all three cloud providers.